Antimatter may be something you've heard of before, particularly if you're a fan of Star Trek, as antimatter provides the energy required for the starship in that show to go boldly, yada yada yada, you get the drill. More on this later. In essence, antimatter is kind of what it says on the tin. It's matter reversed. And an analogy for what this actually is when you're trying to put batteries into something like a torch and you put them in the wrong way. The positively charged bit is where the negatively charged bit should be, and vice versa. It's the same with an antiatom. The protons, the bits inside the centre of the atom that are positively charged, become negatively charged antiprotons, and the electrons, the negatively charged bits that go around the centre of the atom, become positively charged positrons. The existence of antimatter was predicted by Paul Dirac in the Dirac equation in 1928. To explain how the equation predicted antimatter, let's start with a number like 16, which we know is 4 squared. If you multiply 4 by 4, you get 16. However, if you multiply minus 4 by minus 4, you also get 16, as the minuses cancel out, giving you two different square roots of 4 and minus 4. Now let's make it more physicsy. Let's use the equation E equals mc squared. If we square this equation, so multiply everything by itself, we get E squared equals m squared times c to the power of 4. If we then square root it, we get E equals plus minus mc squared, for the same reasons as we saw with 16 earlier. You can get positive and negative results. This means that we can have both positive and negative mass. Positive results, the things that represent matter in this analogy, are so-called evil twins, the negative values. This is very similar to the Star Trek episode Mirror Mirror, where the crew meet anti-versions of themselves. And unfortunately for us, these evil twins have been proven to exist. The positron was first found by Carl Anderson when studying cosmic rays in 1932. Although we know the difference between matter and antimatter, there have been some awesome and mind-blowing theories as to what it is at a deeper level. My favourite, coming from the coolest physicist to ever play the bongos, Richard Feynman, who suggested that antimatter is actually matter travelling backwards in time. It isn't entirely crazy either, due to something called CPT conservation, where C is charge, which we've already spoken about, P is parity, which is directionality, one of the coolest words in physics, which is whether something is left or right-handed, and T stands for time, which I'm assuming you're familiar with. Fortunately for us, we're pretty sure that time is going forwards, as it does for things like electrons that are negatively charged. However, what if an electron has a reverse charge? What if it is positive? What if it is an antimatter electron, a positron? Well, its charge has been reversed, so that must mean its time is reversed as well, meaning it is travelling backwards in time. This then leads us on to the fun and existential crisis-causing symmetrical time hypothesis, which frankly when I found out about just kind of caused me to scream at my screen for half an hour. But let's talk about it anyway. It can kind of be shown in this graph-like thing where the Big Bang is at 0 and the things that happen after the Big Bang are shown on either side. On one side, time is going forwards, and on the other, time is going backwards. What's fun about this is that we don't know which side we're on. We don't know which way time's going. Yay! Although we have ideas as to what antimatter actually is, we don't see why we don't see that much of it. We don't know why it is that the entire observable universe is made of matter. To go back to the Big Bang, the idea is that after the Big Bang, equal quantities of matter and antimatter were in existence. However, this gets confusing when you factor in the Starship Enterprise, because when matter and antimatter come into contact with each other, they annihilate each other, producing enough energy to propel a starship. So how come they didn't just annihilate each other at the Big Bang? How come there is still matter in existence? And how come we don't see any of the antimatter? There have been various theories about this. A couple of years ago, CERN suggested that the rate of flipping from matter to antimatter is slightly lower than the rate of flipping from antimatter to matter, meaning that overall there would be more matter in existence. There are other theories that also suggest that maybe matter has different properties to antimatter, such as gravitational attraction. However, we don't really know. It's one of the biggest and most awesome questions in science today. But even though we don't know why we don't see that much of it naturally, we can still produce it artificially and use it for things like space travel or cancer treatment or PET scanners. For something that kind of explodes when we come into contact with it, it's proving to be awfully useful. Thanks for watching.